Hey everybody, Mark Bates here, and I want to show you some of the changes coming in Packr version 2. This is a complete rewrite of the entire library, yet with almost identical API to version 1. However, it offers some really impressive changes, I think. For example, we no longer use file walking to look for boxes in your app. Instead, we now actually use import paths. So this allows us to actually go through your entire dependency graph and find any boxes in your dependency graph and bring them in, so that way you know you have every single dependent asset or template or migration or whatever you need that your app is going to need in production. And of course that can be disabled if you prefer the old style of walking through the directory path. Other changes are we have changed the way we pack all of our files. So this way, one of the benefits we get there is now any duplicate files. So if you had two boxes that were maybe, say, pointing at the same folder, or two boxes that somehow included the same files, before you were getting duplicates of those same files packed into your binary. This is no longer the case. We're now using a global store, kind of a big cache of all of the files from your application, and then using kind of pointers to point into that cache to resolve your files. So that's going to be a huge win in a lot of applications. You no longer have to worry about accidentally bringing in duplicate copies of the same file. Boxes can now have names. And with this, we can programmatically look up the same box time and time again. So pretend you name your box, My Assets. We can then programmatically from anywhere ask for the My Assets box and know that we're going to get the same box back as the box that was created earlier, and vice versa. So this is a really wonderful way now to work with boxes without having to actually be given a box explicitly. So that's great. We've started using a lot more interfaces. So now you can write your own implementations of boxes. That's awesome. We have created a new way of dealing with storage. Remember earlier I said that we have this new way of packing files. Well, that is just one way. You can go back to the legacy format if you want, or you can write your own store, and we're going to do that in this video. I'm going to write backing for Packr, that when we run a command, it will pack all of our boxes up to S3. And then we're going to write a resolver, which will find the files on S3, and then if not on S3, on our local file system. And we're going to show how that particular change, that resolution, is one line change to our application, which is pretty cool. So there is a ton of stuff here, and I could go on, but I'd rather show you. So let's dive kind of straight into this. So I've got a very basic application here. As you can see, I've got a Packr box. I'm using that box as an HTTP file system, launching on port 3000 and listening. I've got a few templates: foo HTML, index HTML, myfile.go. I am using Go modules, but that's neither here nor there. I will be using Packr version 2 beta 16 for this demo. And we're getting close to releasing our first RC as well. So the only change I need to make to my application at first is switching to Packr/v2. Now, we are following semantic import versioning for the first time in Packr version 2. So this means that it'll work really well with Go modules. It also means we've created a new kind of subfolder in the project tree so that those not using Go modules will still be able to access v2. However, just for those watching, I do want you to note that we are currently using a branch. So if you want to use v2 and you're not using modules, you will need to use dep or some other sort of versioning system to get these into your application. So with that said, my app is quote unquote upgraded. Now, as you can see, there are some deprecations. So that's the first thing we really should do, is go through and look at and fix any deprecations in our application here. So I happen to have the Go doc I believe, running on my local machine, and actually I believe I don't, so I don't. But I do now. Anyway, so you can see we're now, the deprecation message, let's go back and take a look at that real quick here, says, new box has been deprecated, use packr.new instead. So what does packr.new look like? Okay, this takes two things. It takes a name and a path. So remember I said our boxes are now named. So I'm going to update my code here to remove that particular deprecation. You may find other deprecations, so as you go through your app, just simply remove those. And I'm gonna call this this box here my templates. Nothing too fancy here. So I'm gonna stop that. I'm gonna run that again here. Now I'm gonna go to my browser, go to 127, and you can see we've got hello world. And if I open my index file up here, and I modify it slightly, you can see it's picking up the changes as before. So no change in behavior there. If we run Packr2, so there is a new binary. This is called Packr2, conveniently named. This helps us keep the two commands separated, so those who still want to use Packr1 could keep using Packr1. If you do not like the name Packr2, you can obviously just alias that off here. But I'm going to run Packr2, and I'm going to run the -v flag because we've really enhanced the logging here. So you can see what's kind of happening now. A new parser is firing up. We're going to talk about parsing in a little bit. That is going to go and look through my application here. It's going through my application, it's finding boxes. It found one box, it's using a disk store, and it's packing the My Templates box. And you can see that it created a few files there at the end. And so let's look at what we have now. Now we still have, you can see main-packr.go, which is similar to what we had before in Packr. But this time, you can see that all it is instead of calling a bunch of functions and packing bytes and stuff like that, all this does is import the packr.d directory. And so if we look at packr.d, there's now a new package in your system called packr.d. And if we look at packed Packr, you can see this is now where all of our files are being packed into here. And you can see we have a global cache that has a few things in it. In this case, 3 different items in it. They are hexed and gzipped into that package there. And you can see down here, we have our Packr. Actually, before we do that, you can see that on that global box, we have set its resolver. It's what we call a default resolver. And the way resolvers work is we can set up resolvers for individual files as well as defaulting to a box resolver, finally to a global resolver. And resolvers help us find the files when we ask for them. So you can see my templates box is being declared in this file here, and you can see I'm setting a resolver for each of the files in my box. And I'm using what's called a pointer resolver. In this case, all a pointer resolver does is it forwards from the file you're looking for to a different box and a key within that box. So in this case, I'm saying index.html is in my GK box, which is my global box, and its forward path is 48df. So here is that file on line 17. That is the packed version of index.html. And I can show you that that is true. I start my server back up again here. I go to 127. We still see that kind of weird looking hello world. If I open up my index.html file and say fix it, I save it and I refresh, nothing happens. I can even restart the server and you can see nothing gets picked up. So let's just clean that out, and you can see it deleted that packr.d directory as well as any other Packr files. If we go run again, you can see our changes there. Okay, so now let's see what happens when we import another library. In this case, we'll import Buffalo because I know Buffalo has boxes. It's got a bunch of boxes for its generators and stuff. So let's see what happens now when I run Packr2. Oops, let me stop the server here. And I'll run Packr2 -v to show me the complete output of what it's doing here. So you can see that is a significant number of parser runs and all sorts of stuff. And in this case, it found 14 boxes. You can see the fourth one it found here is actually, the fourth one it's packing anyway, is my templates. And the rest are all these other boxes that came from the Buffalo application. And if we go to our packed Packr file and refresh it here, you can see we now have a ton of boxes and such in there. So the really nice part about this is I know that since I'm depending on this library, and this library is depending on these boxes, it's going to work everywhere. And this is huge. This is really, really important. You might not know it, but it is very important when you have this sort of level of connectivity through the boxes here. Of course, you can turn all this off and you can use a more traditional style of packing and resolution here. So you can see there's a couple flags, ignore imports, set to true when Packr won't resolve imports for boxes. And so what that will do is that won't follow our import paths, it'll just follow our directory path. So let's clean that up. And oops, yes, I meant Packr2 clean, of course. And let's run it again, -v, and we'll do ignore imports and see what happens this time. So you see this time we don't have any of the Buffalo boxes were resolved. And if we go back to our file path here, there we go, our Packr path rather, we could see that we only have the stuff from our templates. And of course, we can also pack all of this using a legacy store. So doing --legacy with ignore imports gives us the exact same previous output we used to have. So if I open this up, you can even see it's a_ just like it was before. And we have the exact same files that we had previously. I will tell you this, that the pack.json bytes, for example, is deprecated in v2. So I highly recommend that you eventually move off of this legacy format of packing. Okay, so on to the really fun part of this video. I'm going to write now a little binary, not production ready. I'm not going to release the code, although I do have a gist of it all. In my gists account of Mark Bates on GitHub, so you can check that out. And I'm going to write a tool that will, instead of using Packr, the Packr tool binary, we're going to use this binary. We're going to call it S3 Packr. And what it's going to do is it's going to do just what Packr did, except it's going to run through our application, find all of our boxes, and push them all to S3. And then we're going to write a resolver that we can use in our application to find the boxes on S3 later. So here I've got a very simple application, nothing too crazy. I don't need the version file or even a license, but I will keep the make file because that's always useful. So here I've got my main.go, and first thing I need to do is I'm going to need a list of paths, and we'll get these from the args. This is a list of directories we want to search for boxes. And simple little check here, if paths is 0, then we'll set the path equal to, oops, the current directory here, if I can type. There we go. And now we can get a new parser, and we'll talk about that in just a second here. From the parser package, we'll do new from roots. And we'll give it our paths. These are the directories, like I said, we want to search. And it needs some options, and we'll roots options. And we're not going to do any special options there. Okay, so let's go and look at the parser package here. So I'm going to go back to the Go doc. And here is our parser package here. So let's look at new from roots. New from roots scans the file roots provided and returns a new parser containing the prospects. So prospects are files that could potentially hold boxes. So these are going to almost exclusively be .go files that the parser has found and is ready to potentially work on. So when we find these things, these prospects, we then call run. And what this will do is return either an error or a slice of pointers to a parser box. Now, a parser box is going to give us all the information we need to work with that box programmatically. So, for example, the name of the box, the path. This is, dot, in this case, the relative path of the folder. So .temp/templates here. ABS path is the absolute version of that path. Package is the name of the package the box was found in. This is useful when you're building, say, files that need to be need to have a package at the top. PWD, where was the parser run? Where at the time, but where was the parser running from when this box was found? Great for doing resolutions. The package directory. Now this is the absolute path of the package where the box was found. So all of this stuff here means we can loop, walk directory trees. We can find files. We can do kind of whatever we want with all this information now programmatically. So now we can get all the boxes here from our parser. All right, and we'll do a little error checking. And now we have, hopefully, a list of these parser boxes that we can range over and do something with. And so for right now, I'm just going to print off box.name here. There we go. And let's see, we'll make install. Fantastic. I'm going to go back to my app here and I'm going to run my S3 Packr and see what we get here. And there you go. You can see it found all the boxes, including the Buffalo boxes. So I can now go through all of these boxes and do something with. So what you can do now here that we couldn't do before is we can programmatically look at each box and decide what it is we do with it. So for example, you can write your own Packr tools that maybe pack your templates and whatever that you want inside your binary, so you always have those, but maybe your images and your videos, those get sent off to, some CDN somewhere, and those PDFs get sent up to S3, right? So you can start thinking of all these different things. Maybe you push some stuff into a database. That's where Packr stores certain information, like a config file, so that everybody can read, all your servers can read them and get updated. There's so much you can do with these Packr boxes. You can even write an HTTP store that will do that. So let's not talk about it. Let's actually just do it. Okay, so let's create a new package here. We'll call it S3 Packr. And in there, we'll put an S3 packr.go file. Open that up and set up our S3 Packr. Now I'm going to write a little function here called key. And this is because I know working, I'm pushing all this stuff to S3. I don't want to deal with weird symbols and file names and stuff like that. So what I'm going to do is I'm basically just going to create a SHA of the file name and use that as the key on S3. That way I don't have to worry about any of those things. And since no one's going to see them, it's pretty safe for me to do this. So I'm going to SHA-1, or at least safe-ish for what we're doing in this video here. So I'm just going to write some data in here, and I'm going to write the string, but I'm going to write strings to lower. That way I always have the same thing every time. That way if someone gives me a different file name. And then I'm going to return sprintf here. %x, and we're going to do %s. we need to sum will give us the bytes we need, that is the SHA, and the X will turn it into a nice string for us here. And I'm going to tack on the extension as well, just so that we can easily see what's an HTML file, whatever, in case we ever need that information here. So, okay, that's my key file. Let's actually write the store. But before we write the store, let's go and look at the documentation and see what exactly a store is. So if we look, oops, back one more level. There we go, store. And here we go. A store is an interface down here that has these 4 functions. Takes a box, return for file names, can give you back a list of the names of the files in the box. If given a box, it can give you back a full list of files. These are more complex and have readers and writers, and allows you to work with the file that you found. Pack takes a box, packs the box the way you want it, and clean takes the box and potentially cleans the box here. So there are a few implementations already of stores. There is disk store, which works with a file system, disk obviously, and this is probably the store that most people will kind of hold on to and work with over time. There is a legacy store. This is the older store that we had that did what we needed it to do, and that we used to use, and now we can use, still obviously, but it is legacy. And then a function store, which allows you to define functions for all of the different things you want to do, and it will call those functions and create little kind of simple stores for you. But we're going to write our own store, but we are going to use the disk store to flesh out the implementation, especially since we want to be able to fall back to disk should our files not be found on S3. Okay, so let's start writing our store here. So I'm going to create store.go, set it to the S3 Packr package. And then I'm going to create a new type. We'll call it S3 store. It's going to be a struct, and it's going to have a pointer to store disk inside of it here. So that by embedding the store disk, we will have a complete implementation of the store protocol that is backed by disk for us. And we can prove that here by creating store.store and assigning it to a what is going to be a pointer type. And we could see that it compiles. We don't have any errors. So I'm going to create a new function that takes a pointer to a parser box and returns an S3 store here. So we'll say return S3 store, and then we have to create a new disk inside it. And since we have information about the box, we can pass that information in. So new disk needs the absolute path to the box on disk, and it also needs a package that this box is quote unquote in. And with that, we now have a fancy disk store called S3 store. It doesn't do much for us. What we really need to do, though, is implement the pack method. That's the thing that for our purposes is of the utmost usefulness here. So let's implement the stub of that here, which looks like this. Okay, so that is going to be our implementation. I'm going to also add a simple little debug statement here that tells us a little more information. And plog is a package under Packr v2 that has a logger and a simple debug log to it. And the only reason it's there is to let everybody access to it due to import paths and stuff like that. But okay, what we really need to do inside our Packr box is we need to find the files we want to walk. Now we want to send up. I'm going to use the absolute path here, and I'm going to create my walker function. Now again, just a reminder, this is not production code, so I'm not going to do all the necessary, real heavy checks you would do if this was, say, a production piece of code here. This is more for just demo purposes. I'm hoping that maybe an industrious person out there might take this and make this production ready. Anyway, we're going to ignore any directories because we're just packing files. And then we'll say, we'll call some upload feature that has the box name and the path. Now, obviously, we don't have an upload, so let's make sure, and that's isdir. There we go. So let's go and add that upload method here, and it's going to be on our S3 store. And it's going to upload, it's going to take the name of the box and the path of the file that it wants to upload here. And then I'm going to do a little off-screen magic and paste in some code. I'll be right back. Okay, so what did I do off screen? Well, what I did off screen was I plumbed in the actual connections to S3, and I'll walk you through them. I just didn't think you wanted to sit there and see me type all this kind of stuff here. So I am using here the new GoCloud packages. If you haven't seen these are a new set of interfaces and types that the Go team is trying to get out there that allow for kind of a rich way of working with clouds. So in this case, I'm going to use the blob interface that it lets me work with any sort of blob storage, whether it be file storage or in this case, S3 blob. So what I've done here is I've created this with bucket method that takes a function. That function will get a context and a pointer to a blob bucket. Inside of there, I've got a simple timeout, a 1-second timeout. I'm getting all my S3 keys and the like. I am creating a new AWS config, setting its region to US East 1, where I've created my bucket already off screen. It is on S3 waiting for us. I'm going to create a new session. I'm going to open the bucket, which is called S3 Packr demo. I'm going to call the function here that will pass back the bucket and what have you, and it'll nicely close everything when I do defer buck.close. I believe, right? Nope, doesn't have a close. Sorry. This will just clean up our code a lot. So inside of my upload method, I'm calling with bucket, giving it that function. With the bucket I get, I'm creating a new writer. Now remember, this is a nice kind of implementation here that is not, at this point, this could be a file system. This could be S3. There's no actual S3 code now inside of my upload file here, function rather, which is kind of cool. I'm going to give it an octet stream upload. I'm going to get the file off disk, copy it into my writer, and then that's it, right? My writer will close, my file will close. And that is it. That will now upload all of my stuff to S3. So let's make install that. And everything looks good here. Let's go to my site and run S3 Packr again. Let's go to transmit. We'll refresh that folder and see what we get here. And we get nothing because we never actually plumbed it in. I know, right? Back to main.go here. Sorry about that. You know, can't all be perfect. But plumbing it in is pretty easy here. Let's just call it now. All we got to do is we'll say S3 pack the box, and S3, actually we'll put that up there, S3 Packr dots new box. There we go. And we'll just log.fatal if there's an error here. And there we go. Okay, now it's all plumbed in. We're looping through our boxes, calling S3 Packr, packing it, and then that's it. So now that we've actually plumbed it in, let's install it again. Go back to our app, run S3 Packr. There you go. A little slower that time. But whoa, look at all that. We've got all these files now in S3, and you can see there's temple, plush, there's all sorts of files now in S3, which is great, which is exactly where we wanted all of those files. And it didn't take much code to actually do, nor did we have to make any changes to our application to pack our files up there. One change I will make here is I'm going to change the logger on Packr so that you can see what is happening inside of our S3 Packr here. Whoops. There we go. So I've set it up now to be a debug at the debug level. So you can see it's gone through, it's parsed all of our Go files, and then you can see it's going through using the S3 store, and it's packing all of the information. In this case, this came from a Jenny example, and pushed all of that up to S3. Okay, so with all of our files on S3, how are we going to find them? How is our app going to find these files on S3? And if you see, let me run the app here, and you'll see the problem we have. If I go back to my index here, it's still serving up, but it's serving up off of disk. And I can prove that, right, by making a silly change again. And it's still being served up live. We need to serve up our files via S3. And using resolvers in Packr v2, it's just a matter of implementing the right interface here. So let's write a resolver. And again, this is the S3 Packr directory here. We're going to create a new type, we'll call it resolver. And we're going to hold a resolver. We're going to embed a resolver disk into our application here. And let me oops, not resolve disk, that's resolver. And let's go and look at resolvers in the documentation and see what they are all about here. And resolvers. Here you go. A resolver is a very simple interface that has one method called resolve that takes two strings. The first string is a box, the second string is the name of the thing you're trying to resolve, and it returns a file interface or an error. Now, there are a bunch of resolvers already implemented for you. A disk resolver, which, as you can imagine, resolves files to disk, and this is used by the disk store as well. Hex gzip is used to resolve files that have been hexed and gzipped. This is used, as we saw earlier, in that Packr global cache to resolve those files. And in memory, this is a simple resolver that just resolves things in memory. When you do add bytes or add string to your box, you're getting an in-memory resolver to back it so that it knows what to do. So to implement our own resolver shouldn't be, hopefully, too hard, knowing that we've got a disk resolver, which means we have the thing somebody's already written, me, a way to resolve to disk should the files not exist in S3, so we just need a way to resolve them on S3. I'm going to write a very simple new method here that returns our resolver.resolver, and we will return our new resolver struct with a new resolver disk embedded into it here, and that needs root And our root will be what here. I'm gonna just hard code my root for now because why not? And this is called, I believe, Mark Bates, my site, right? Yeah. Okay. So that's where it will try to resolve files should they not exist on S3. Now we just need to implement the actual resolution of the resolve function here to go and look at our our S3 repo instead. So path with string, and we're going to return a file, and an error. So I'm going to create, now file.file is an interface, and we can look at that interface here as well. To file. Here we go. It is actually a packed file. And here's that file. It's a HTTP file. You can see it involves a bunch of different interfaces. Now the good news is there are functions that create new files for you, so we're not going to have to worry too much about that. Now we need to set up our key. Now our key that we used in our store, if we look somewhere along the way here, where is the upload method, is box is our key here is box plus path. So we got to make sure we do the same thing here, box plus path, so we have identical keys. Again, we're going to use our bucket, our with bucket method to talk to S3 and set up the bucket so we don't have to do that every single time here. And this is what that function looks like. And so with that, we can open up a new reader on our bucket using the context and using the key. And of course, if there's any errors, we're going to return those. So hopefully we have a bucket, and if we don't have a bucket, this will fail. But that's fine, and we'll see why, because we're going to try to resolve to disk next if we find anything here. Assuming that we create the new reader here, we'll defer the closing of that reader. Then we were going to get the file, we're going to create a new file here from that reader, giving it the path, and we will return the error. Now, what we want to do down here is I'm not going to check the error, but rather I'm just going to check if the file is nil or not. There are reasons why I'm not doing it. It mostly just has to do with, again, this being a simple demo, not production code, and not wanting to spend the time explaining all the various levels of error checking I would have to do to keep the same flow here. Whereas this is good enough for my purposes. So if f is not nil, that means we found the file is good, we will return back here. And this actually shouldn't be R, this should be F. There we go. Assuming that the file is still nil, we're going to use our disk resolver to resolve it by giving it the box and the string. Again, we're going to do that. We're going to try one last time. Actually, yeah, oops, sorry, I'm going to do that. And you know what, I can probably, yeah, we'll just keep it like that. And then finally, F and nil. So, what do we do here? Blob reader as type, yes, I believe it was it. There we go. Wrong function call there. And yes, that is, we're not returning enough things. Okay, so now we should have our resolver. And to use our resolver, all we need to do is import it into our application and set, in this case, I'm going to set the box's default resolver equals to S3 Packr new resolver. And that's it. Let's start up our application again here. I'm gonna have to turn off modules for this here, so that it picks it up on my Go path instead. The package we want here. You can see I'm getting the original Hello World versus this crazy messed up one here, because that is what is on S3. And I can prove that if I go to S3 here and delete all of the files on S3, if I refresh, it's falling back to disk and finding the file as it did before. It's right off the disk here. And we can, again, prove that by fixing the index HTML. So that is it. That is your very quick tour. Well over 30 minutes. A lot longer than I thought it was going to be, of Packr V2 and just some of the things it can do. We have looked at how it maintains, although deprecated, the same API as before, making it easy to switch to V2. All you have to do is kind of go through and clean up your deprecations. We've seen that there's new file formats, better packing. You can build your own storage and resolution systems, as we did with S3, which is, I think, again, incredible. And having this level of flexibility is going to open up not just the Buffalo team to do some really fun things with Packr, but I hope everybody out there who uses Packr and the packed interfaces, which we didn't even get a real chance to look at, but we'll look at super quick here. We now have a full set of interfaces that let you write Packr v116 and above and Packr v2 implementations of boxes. So both those versions of Packr 116 and above and Packr v2 use interfaces now. And so we can, or rather, they implement the packed box interface. So this means you can write your own box implementations as well, which is also kind of cool, including the memory, and Packed actually even has a memory box implementation that you can use as a packed box for testing and the like, so you don't actually have to have a file system to back your Packr boxes and testing. You can use a memory box. And anyway, that's it. This is a very long video, much longer than I wanted it to be, and I apologize. Please go and check out Packr 2, play with it, use it, open issues. Let's make this a very stable, solid, smooth release. And that is it. I hope this helps. This video was brought to you by Gopher Guides. If you're an organization, conference, or user group that is looking for Go training, please visit gopherguides.com. All training is custom designed to match your educational needs.